So in this lesson, we're going to go over some factoring techniques. And we're specifically interested in making sure we review how to factor quadratics and how to factor polynomials that are of higher degree. So first thing I wanted to review with you, just to make sure we are all on the same page, is what a polynomial is. So a polynomial, remember, is a function that can be written as in this format. And remember, the little numbers at the bottom means like first, second, third. So this is saying the highest degree, and then this is saying 1 degree lower, etc. And remember, it's going to have integer coefficients if it's a polynomial, and you're always going to write it in standard form. It would be in descending order. We'll work on that a little bit more, but again, we're just reviewing. Let's go ahead and look at this polynomial. So this is a binomial that's a 5th degree polynomial. Binomial because it has 2 terms, 5th degree because the highest exponent I see is 5. So let's go ahead and factor it. So the technique I'm going to use for the factoring this is I'm going to be using common factor. So I'm going to look at each term, and I want to know from each term, this term and this term, is there anything I can divide that's in common with both of them? So when I'm comparing the numbers 3 and 12, I know that 3 times 1 and 3 times 4 make each of those numbers. So 3 is a common factor. When I go and I look at the variable factors, x to the 5th and x to the 4th, if I wrote out x to the 5th, 1, 2, 3, 4, 5, and I looked at x to the 4th written out, 1, 2, 3, 4, I see they have 4 x's in common. So that's my common factor. So when I write something in factored form, remember what I'm doing is I'm trying to write it as a multiplication problem, basically. So I'm saying 3 times x to the 4th times what is going to give me this original expression that I have. So if I multiply x to the 4th times x to the 1st, I get 3x to the 5th. So this is the remaining factor when I take out 3x to the 4th. And if I multiply 3x to the 4th by what would I get 12x to the 4th? Well, 3 times 4 makes the 12. And x to the 4th times 1 makes x to the 4th, which means my second factor is just a 4. But it's positive times what kind of number makes a negative, and that would be a negative. So it factors to 3x to the 4th times x minus 4. You can't factor a linear factor anymore, so this one is as good as it gets. Even though this one is a 4th degree, it only has 1 term, so I can't factor it any further. So my answer would be this, and that's common factor. Okay, now we're going to focus for a bit just on quadratics. This is a special case, and it's specifically known as difference of squares. Difference, because difference, remember, means subtraction. Squares, because the first term must be something that's exactly a perfect square, and the second term must be something that's exactly a perfect square. So let's look at this one and see why it fits a difference of squares. Well, 9 is 3 times 3, and x, of course, is x times x. 16 is 4 times 4, and in between them, I see a minus sign, so it meets the criteria for difference of squares. And how it works to factor, remember, is this happens to be the square root of a squared. So I take the square root of the first term, write it down, take the square root of the second term, write it down, put a plus in between the first set, copy it again, but change the sign to minus. Super easy, so she said. So let's go ahead and do this one. Okay, so we said that to make 9x squared, I had to square 3 and an x. To make a 16, I had to square a 4. So it's 3x minus 4, and then my second set would be the same thing except an addition sign. And it works out. I can check by doing FOIL. 3x times 3x, 9x squared. 3x times positive 4, negative 4 times 3x, and negative 4 times 4. 12x and negative 12x cancel, leaving me 9x squared minus 16. So let's go ahead and look at factoring a quadratic. So this quadratic is quadratic because the exponent is 2, and one of the things we know about it is it's a trinomial. There's no common factor, so I can't use that method. So I'm going to have another way of doing this. So when I'm looking at this, the first thing I'm going to look at is what is the leading coefficient. If the leading coefficient is 1, then I can go ahead and I can reason this out. When you have a factorable quadratic, it's always going to be factoring to the product of two binomials, so two terms. And I can go ahead and I can look at this and I can say, okay, well, because this is a plus sign, I need this and this number right here to multiply to positive 14. That means they both have to be positive or they both have to be negative, but they need to multiply to 14. So let's look at our pairs that multiply to 14. So I could have 1 times 14, or I could have 2 times 7. The second thing I'm going to look at is I'm going to look at the sign of the middle term, because that tells me that if the signs both have to be the same, this one tells me what they actually have to be. So that means they both have to be negative because the 9 is negative. And what I want is I want them to add up to negative 9. So if I add negative 1 and negative 14, I would get negative 15. And if I add negative 2 to negative 7, I would get negative 9. So what's the pair of numbers I need? Negative 2 and negative 7. So I'm going to put in my negative 2 and my negative 7. And then because this is just x squared, the only way I can get x squared is by multiplying x times x. And if I go ahead and I use FOIL and I do all that multiplication, I'm going to go ahead and reintroduce that little multiplication box. X minus 2 times x minus 7. X squared, negative 2x, negative 7x, positive 14. Negative 2 and negative 7 makes negative 9x. So I have x squared minus 9x plus 14, exactly what I started with. Okay, let's look at another one. So this one says x squared plus 2x minus 24. So now when I'm looking at this number, that's what I want the number. It's going to be a binomial times a binomial. So I need these two numbers to multiply to negative 24. Remember, the only way you can get a negative number is by multiplying a positive number times a negative. Now, when those two numbers add up, I need them to add up to a positive. That tells me something very important. It tells me that this factor that's positive has to be the biggest one. This factor that's negative has to be the smaller of the two numbers. So let's look at pairs. So I could have 24 times 1. I could have 12 times 2. I could have 6 times 4. And I missed one, 8 and 3. So if I go ahead and add, remember this left column is positive numbers, to the negative numbers that are in the right column. 12 and negative 2 would make 10. 6 and negative 4 would make 2. Positive 6, negative 4. 8 and negative 3 would make 5. So that eliminates all of them but 6, positive 6 and negative 4. So I know this is positive 6 and this is negative 4. And the only way to get x squared is to do x times x. Okay, when I do this one, I'm going to introduce something that is a graphic organizer that I like to use. And I like to call this the Xbox method. So doing this one, I want to look at a target product, which means what are they going to multiply to, and a target sum for choosing these two numbers that I'm going to go ahead and use. So my product always comes from the leading coefficient times the constant, so that's negative 42. And my target sum always comes from the coefficient of the middle term, negative 11. So what this is saying is I need two numbers, and those two numbers have to multiply to negative 42, and those same two numbers have to have a sum of negative 11. Well, I know right away because my product target is negative, one has to be negative and one has to be positive. And my target sum being negative means that this negative number has to be bigger than whatever the positive number's absolute value is. So let's go ahead and take 42 and do a little list. So this time we want the big number to be negative, smaller number, and by that I mean the absolute values, of course, has to be positive. So I could have 42 and 1, but negative 42 and 1 doesn't make negative 11. I could have 21 and 2, but again, those do not have a sum of negative 11. I could have something like 14 and 3. I could also have something like 7 and 6. And that's about all my choices are. So do any of these meet the criteria of adding up to negative 11? Well, I see right here that 14 and 3 are 11 apart, and that's because negative 14 and positive 3 make negative 11. So that means my two numbers have to be negative 14 and 3. Now, this graphic organizer isn't the only way to do this, but this is one way that you can approach it. And some people need it step by step. So let's go ahead and look at what we actually are doing. So what we're saying is that 6x squared minus 14x plus 3x minus 7. And remember, the negative 14 and the 3 came from those two numbers. Well, if I had negative 14x and 3x, I actually get back that negative 11 that I had. So what I'm doing is taking it and writing it and putting it into a group of 4 terms instead of a group of 3 terms because it's easy to factor by grouping. And the box organizes things for us. So when I'm looking at the box, I'm doing the opposite of what we did with multiplying polynomials. I'm dividing out common factors now. So when I'm looking at this column right here, what divides 6 and 3? 3. But I see I have x squared and x, and the greatest common factor would be x. And when I get to here, if the first number is negative, I write a negative. And then, or I should say first term is negative, I write a negative. And I see that 7 and 14 have a common factor of 7. Since both don't have an x, this is the only one that has an x, but this one doesn't have the x, that means I can only take out a negative 7. Now I'm going to go ahead and go here. So now I'm looking this way. What does 6 and 14 have in common? 2. I'm going to put positive 2 since the 6 is positive. And now I look at the x factors, and they have x to the first in common. Now I'm going to go ahead and look at this next row. Since 3 is positive, I'm going to put a plus. And now here's the case. 3 and 7 have nothing in common. Only one of the terms has an x in it. So the common factor is just a 1. So now it tells me that my two binomials are 3x minus 7 and 2x plus 1. Okay, let's look at this one. Now, it has some big numbers, but let's go ahead and try anyway. So first I'm going to think about what's my target product. So I'm multiplying the leading term by the constant. That gives me 120x squared. So I'm looking for two numbers that multiply to 120. And now my target sum is 23. So they agree to be positive. So I'm looking for two positive numbers that add up to 23 and multiply to 120. So 120 has a lot more factors, but let's just go ahead and try two. I know they both have to be positive this time, so that's helpful. So if I did 1 times 120, that's 121. So let's go ahead and break it down a little bit more. Let's say we go ahead and we did 6 times 20. Well, now they add up to 26. I'm getting closer though. So let's say I did 12 and 10. Now they add up to 22. Okay, so when you do get kind of stuck and it's a big number, which hopefully we won't use that often, you can always do a factor tree. So let's try 8 and 15, because 8 times 15 also makes 120. And what do 8 and 15 add up to? 23. So that's our two numbers. Okay, so remember, once we had those numbers, we went ahead and we took the first term, that's quadratic, the last term, which is our constant. Then we go ahead and we put an x next to these and put them in our boxes. And now we're ready to factor. So we're going to go column, column, row, row. 6x squared and 15x share a 3 and an x. 8 and 20 share a positive 4, but not an x. 6x squared and 8x share a 2 and an x. 15x and 20 share a positive 5, but not an x. So this factors to 3x plus 4 times 2x plus